So I'm going to talk about there are different kinds of interviews that you're likely to get. And we've been doing a lot of practice with kind of soft skill HR kind of interviews. Tell me about yourself, tell me about a time you worked on a team. And then you also have the nitty gritty, write me an algorithm that, finds the sum of two numbers in an array or whatever. So there's all kinds of, there's very low level algorithm kind of, can you code, can you think through like a very specific problem and implement the solution. There's also a very loose kind of, are you, someone I want to work with, someone I want to be around. And then I'd say you're also going to get kind of questions that are in the middle, that are technical, but not, that don't require you to like implement the nitty gritty details. And one of those kinds of questions, I think a general category is system design. So a system design interview, like the algorithm question, it could be fairly simple, could be yeah, fairly simple, or it could be extremely complex, and the level that you're going to be expected to perform at will vary depending on the level of the job that you're applying for. So if you're applying for head of engineering at Google or something, you're going to get one kind of interview with one set of expectations, and if you're a junior developer for whatever random company, you'll have another. So what I'm going to go over is something a level of a fairly low level for a junior software engineer. Are you guaranteed to get a system design interview question? I'd say no. But you'll probably be asked something like in the ballpark. So I think it's good to be familiar with the structure of applications as a general thing. If you really get into it, this is you can get very specific about techniques, and there are kind of set expectations, but the takeaway I would want you guys to have is just in general having being able to explain at a high level how a system works. All right, so there's an example here, and I kind of you can read through this later, but the way that this interview will work typically is you'll have some kind of drawing tool. So instead of writing code, you're going to write some diagrams. And the question will be something like, design me Netflix, or design me an email service, or design me Twitter. So you can pick a random, they'll ask you to design some system. Oftentimes it'll be based on something that actually exists, that you're familiar with. And basically what you want to do is you want to, it's a little tricky at first, because when someone says you have half an hour to design me Twitter, it's just like, oh, what am I going to do? They don't want you to get into every single nitty gritty detail about everything. They're asking about high level stuff. So I'll just kind of walk through an example. Yeah. So if I got asked a question like in this example, like, design a basic social media platform, or design a blog. I'll just say design a blog. Well, what you're going to first do is the interviewer is going to say design a blog. And then just like any other interview, you're not going to just start writing stuff out, right? In an algorithm interview, you don't just immediately start writing code, you ask questions. Make sure that you understand the problem. So the kinds of questions that you're going to be asked, that you're going to ask, just to make sure that you understand the basic output of the system. So what should a user be able to do? So if I design a blog, I would ask questions like, well, what should a user be able to do? Okay, a user can write a blog post. Can a user write comments? Can a user comment on a post? Can a user comment on another post? Can they comment on their own post? Can they follow other users, etc.? So asking basic questions about what what this what the user can do. And again, you want to avoid super detailed questions about like, what specific authentication implementation should I use or blah, blah, blah. So you don't want to go into those like details. Okay, so you ask questions, you understand what the basic system is supposed to do. And then at that point, you start drawing a high level sketch of the components involved. So if I have a blog, well, okay, I'm a user. I have my laptop or whatever, my phone. I'm gonna go to an internet address, an IP address, and I'm gonna get an HTML document. So something like that. How's that gonna work? So you'd start with, okay, so I'll just do this for a client. So I have a client, and that client is going to make a request to a web server, let's say. Okay, so that client is going to make a request to a web server, and what's going to happen? What's going to happen then? Well, that web server is probably going to have to communicate with a database. Okay, because we're going to have to store user information and etc. So we're going to have a database. Okay, so at a very, very high level, we have these basic components. We have a client, and the client is going to communicate to the web server, and the web server is going to communicate with the database. So you might also sketch out the flow of information here. So you have an arrow. So request is going to go here, and then request is going to go here, and then there's also going to be a return route. So we're going to go back here and then go back here. Right, so client makes a request to the web server processes it, hits the database, maybe stores whatever, and then responds. Now, at this point, you would want to ask the interview, okay, does this seem like a reasonable high-level architecture? Do you want to check in with the interviewer to make sure that, there's not some specific thing they want you to talk about or add or subtract or whatever? Let's say in this case, they say, yeah, that's fine, but is the web server going to directly communicate with the database? They might ask you a question like that or give you a hint or, kind of communicate what they want. So in this case, they don't like this implementation. So we're going to add another layer here. We're going to add an API layer. We're going to add an API. So we could put that really anywhere, but let's just say we'll put it here for now. Yeah, so the client will make a request to the web server. The web server will talk to the API, and the API will talk to the database, and then the database will respond to the API. The API will respond to the web server. So something like this. Okay, and then you check in. Okay, at a high level, this is an acceptable diagram. So client makes an HTTP request to the web server that contains information, goes to the API, does whatever processing, goes to the database, etc. Okay, so this is a high level architecture. So something like this would be at a junior level. I think something like this is fine. And then if your interviewer is kind of happy with this general outline, you're probably going to start asking you more detailed questions about a specific component. So the system design interview is often it's often concerned about like things like scalability. So this right here, what we have, the diagram of the system, these are called functional requirements. So a functional requirement is basically what are all the things that have to exist in order for this to work. Non-functional requirements are things like scalability. What happens if you now, instead of having 1,000 users, you have 1 billion users or 1 million users or whatever? Things like security, things like latency requirements, stuff like that. So functional requirements is basically like designing the system with all the components, and non-functional requirements are how does the system like perform? What are the other constraints? And for more advanced stuff, that's where the focus is going to be. But for lower level stuff, we'll focus on this. So so at this point, your interviewer is basically happy with the structure. But now we have a question. For example, can you talk a little bit about the data model? So I'm going to ask. I'm going to call on someone. So if the interviewer now wanted you to dive in a little bit about the data model. So again, this is a blog application. So Philip.
Okay. So I would assume that we have like a user model, I guess. That would like potentially have like posts or something like comments attached to them, like a list.
Okay, great. Yeah, so that's good. So for this question, the data model question, so what you want to do is aim for like a very schematic understanding. So you don't want to get in the, oh, it's going to have this column and there's going to be a foreign key from here to here, and there's going to have this other column, it's going to be this data type and blah, blah, blah. So you're not, they're not getting into like the nitty gritty of the table, but it's basically like, okay, you have users and then you have posts, or maybe users, posts, and comments. And you can confirm with the interview is, is users and posts good enough? So let's just say users and posts is good enough for now. So then in the database, we might do something like we have, actually, I guess I'll use, why not use another shape?
Would you want to ask like what type of database? Whether it's SQL, NoSQL.
Yes. Yeah. So yeah, that's a great thought. The first part, yeah, we'll talk about this and then we'll talk about that other stuff in just a second. So first we have users. So I have the user database or user table. Maybe we're not quite sure yet. Doesn't matter. And then we also have posts. Okay. Tamio, okay, that's great. So yeah, you have users and posts. That makes sense to me. So maybe we have two different databases here. Can you talk to me about what specific kinds of database or storage you would want to use for users and posts?
Yeah, so I'd probably want to use something with more structure. So think about using the SQL database,
Okay.
PostgreSQL, just to store the users and the posts and tables that are able to talk to each other essentially.
Okay, great. So yeah, so you think that so you want to use structured data. So you think that both users and posts, it's best to model this having structured data because users maybe connects to lots of other things.
Correct, yes.
So if you have data which is connected to lots of other kinds of data, then oftentimes a relational data model, as in connects to other things, So SQL is very good for that. So an example of a SQL or relational SQL database is Postgres, which you're familiar with, or MySQL. There's a ton of them. And then the other kind of database at a very basic level, there's SQL, and then there's NoSQL. So what's a NoSQL database?
Something like MongoDB, so it has no relation. Not everything there has a relation, essentially.
Yeah. So there's there are different kinds of NoSQL databases, but at a basic level, it's data which is not structured. So if I create SQL tables, I have to be very specific about how it's structured, right? Here's the table, it has these columns, it connects to this other table, which connects to this other table. And any time I insert data, it has to adhere to that structure. A NoSQL database doesn't always have a fixed structure. So it's more like just like an object or a dictionary in Python. So, or basically JSON. I think that's probably the best way of thinking about it. It's if I want to save something, it's just JSON, and it could have different keys. Maybe like every item has slightly different values or different types or whatever. There's a couple of advantages and disadvantages which we're not going to get into. I have some references which you can look at, but basically NoSQL databases are easier to scale. They scale easier because they don't have all these dependencies on other stuff. If you have a SQL database, there are ways to scale. You can use something like sharding, which is basically you take your data and you divide it up into different chunks and you create new databases for each chunk. But yeah, all that stuff is more advanced. But just in general, if you understand, like, here's a SQL database, here's a NoSQL database, maybe some like a couple like pluses and minuses of one versus the other. So yeah, so you could definitely use SQL, a SQL relational database for both of these. But let's just say I'm an interviewer and I push back a little bit and I say, so posts, let's say that posts could be thousands of words. It could be a short little like sentence or two, or it could be extremely long text, and maybe that text has it's like structured text. It has it's like markdown, or it could have HTML elements or something like that. So it's arbitrarily large text. Would that change your decision about whether to use a relational or non-relational database?
Is this directed towards me?
I'll pick on someone else. So Noel.
You said you did want it to scale. So
So initially I'll just say you. So you said that you wanted to have a relational data model for both users and posts, and you explained why, because users is very structured, it's connected to lots of other things, so it's important, blah blah blah. We want to have but posts you put it in the same bucket. So I pushed back and said, well, I'm not sure that a relational database is best for posts. So you can respond.
okay, so we could use a non-relational database like maybe MongoDB. Yeah.
Okay, so why would you do that?
It scales better.
Okay.
I honestly don't really know much about anything other than Postgres.
Yeah, that's fine. Yeah, I'm not really expecting. I'm kind of just walking through this as an exercise to expose everyone. But
I made a note to look it up.
So yeah, if I were the interviewer, and I gave you a hint like, posts could have arbitrarily long data, something like that. and it's also something that gets like written once, right? If I write a post, am I like constantly updating it or whatever? I mean, not really. And if you think about something like Twitter, like, yeah, I guess technically you can edit tweets now, but really it's like it's write once and read millions of times. So data like that is often good for NoSQL, or NoSQL is good for that kind of thing. So we have arbitrarily long stuff. You don't necessarily want to store like huge stuff in a SQL database either. Okay, cool. Good. So now we have this database. So I'm just gonna put this stuff over here. So this is our database now. And I'm gonna mark this one as oops. So this is going to be relational, and then this one is going to be.
Hey Chad, would this impact whether our system is considered, I guess, using microservices? Because I know that's one thing that is like kind of new, and there's a lot of like old companies like migrating from like monolithic systems to microservices. So I guess it's just like at a high level, like what makes your system a monolith versus what makes it like being able to use microservices. And on our projects, does that classify into any of those?
Yeah. So your project, the way that like the default way that that your projects are designed, it's basically a microservices architecture. You have a web server, which is independent of the API, and the API is independent of the database. So it just so happens that we're using Docker Compose, and we have those 3 containers on one server, but it would be very, very easy to put all of those components on different ECS servers. So you could have your database run on one ECS server, and your API run on a different ECS server, and your web server run on yet a third. And then from there, it would also be easy to scale. So let's talk about scaling. So this database stuff is slightly more complicated. So let's just say that we now have a whole bunch more traffic, right? So this system design looks pretty good, blah, blah, blah. But now instead of, thousands of users per day, you have millions of users per day. And your performance is starting to degrade. So how would you handle a significant increase in traffic? Anyone can jump in.
Take it to the cloud.
Do you just increase the amount of servers or like workers and stuff for your configuration?
Okay, so what are there are basically 2 types of scaling. Does anyone know what the 2 types of scaling are?
Can you scale like the amount of data you can store, but you can also scale the speed at like your network size.
Okay, yeah,
Like
well, we'll hold that thought for just a second. But so let me give you an example. I don't play video games, but let's say I buy this, cool video game, and I have an old computer, and it's just really slow and it lags and stuff. How do I solve that problem?
You get a new computer.
Yeah, I get a new computer with more RAM and more processors or whatever. So I scale up my system, right? So I have, there's something I want to do. The performance is degraded, so I scale up. So that's an example of what's called vertical scaling. So I add more RAM, or I add more CPUs or whatever.
So that would be like when you go to AWS and you have different systems that you get, there's a free tier, but then you can see, oh, there's a Mac OS with this many RAM, like almost like the one I have at home. Like, is that what you mean by that? Like
Yes.
getting a more expensive one?
Yeah, for example, like for your projects, you guys are using the free tier, like was it T2 micro or whatever. If you started getting more traffic and all of a sudden there are performance problems, well, you have one option would be to like, okay, I'm going to use the, a larger ECS or EC2 instance, right? So instead of T2 micro, I'm going to use whatever, M6 ultra, whatever, with 10, 100 gigs of RAM. I mean, you can basically arbitrarily scale up with AWS. So that's called vertical scaling. So add more resources to the same computer, basically. The other kind of scaling is called horizontal scaling. And this kind of ties in with microservices a little bit. So horizontal scaling is I'm going to add more instances. So instead of having my web server and make it an even bigger web server, I'm now going to have 10 web servers. So, horizontal versus vertical scaling. So I'm going to now scale my web server. So now I'm going to have a bunch of web servers. Oops. So is there any like obvious problem with this?
I guess how all the web servers like communicate to the API or like I guess stay in sync.
Yeah. So that's
traffic conductor is what you need.
Okay, that's a good thought as well. So yeah, a couple things so we need to make sure that that the kind of data we're dealing with and the kind of component this is actually capable of scaling vertically, right? Because if we have a database, can we just make 10 copies of our database and run them on 10 different servers? So that doesn't really work because then you have 10 independent databases. Those databases don't talk to each other. So they're not really coordinated. You've scaled up, but now you lost control over your data. A web server can scale up pretty easily. But so why can a web server scale up? Whereas a database, it's not so straightforward.
Is it because the web server is only handling the requests? So once the request has been handled, don't need it no more.
Exactly. So the more technical term for that would be a web server is stateless. So HTTP traffic is stateless. The web server, it gets all the information it needs like at this moment from the request, and then it does something with it. And then as you said, it's gone. So that is that makes it easy to horizontally scale a web server without worrying too much. Now, once you do that, as you pointed out, Tyler, now we just have 3 independent things. So we have 3 separate IP addresses, maybe for all of these, and then we have different, anyway. So what you need is now some other central node, which could be a load balancer. And a load balancer is basically going to be the thing that clients talk to directly now. So this will be the interface that a client will talk to. So the client will make a request, and the load balancer will then distribute traffic to different web server instances.
So what is a load balancer in the sense that is it an API? Is it a database? Like how does it structure?
Yeah, basically it's another HTTP server. So it's basically just a server.
Okay.
But it has a specific purpose. So it's usually called a load balancer. There's like API gateway. There's a few different similar kinds of things, but it's basically it's an HTTP server. And its job is to take incoming traffic from clients and then route it out elsewhere.
So is it just like configured with an algorithm of like how traffic should be distributed, basically?
Yep, yeah, and there are a bunch of different kinds of algorithms. So the simplest one is basically called a round robin. So the load balancer will know, when it's configured, or this could be dynamic or whatever. It'll know how many web servers it can talk to, and then each time it gets a request, the first request goes here, the second request goes here, the third request goes here, the fourth request goes here. So it will just round robin. So every request goes just to a different server, and that's it. Are there any potential problems with that?
Latency.
Okay, good. Can you talk more about?
Since we added an additional layer, I'm assuming that's going to affect the time it takes to make your requests.
Okay, great. Yeah, that's a great point. So yeah, we've now introduced yet another step that a request and response have to go through. So that can introduce latency for sure. What about specifically this round robin algorithm for distributing requests from the load balancer to the web servers? Is there any potential problem with that? It sounds fair, right? It's like seems reasonable to me.
Would you have to like rewrite it every time the like amount of workers change or the amount of servers change, or I guess like ensure that the algorithm is dynamic?
Okay, so that's definitely one thing to think about. So if I add, let's say there's even more traffic now, I want to add a fourth web server. How does this load balancer know about that? Does the load balancer get this configuration dynamically? Does it pull some other? Is there another service, for example? So we're talking about microservices. So now we have another service over here, which is web server manager or something like that. And the load balancer will now talk to the web server. It'll just, let's say, constantly pull the web server manager to figure out what web servers exist. And that web server can send a response. Oops. Yeah. Anyway, I'm not going to draw that out, but yeah. So that'll be one way of handling this. And then if I want to add another web server, I just basically tell the web server manager, and then that communicates to the load balancer, and then the load balancer knows. So that would be one potential. So this would be an example of a microservice. So what happens if this web server goes down? This guy's doing round robin requests. What's going to happen?
It's going to change it, right?
Those requests will
When
fail.
you yeah, imagine when you configure your load balancer and your web server manager, they're configured so that the web servers can handle like a specific capacity. So if you have one of them go down, then likely others might go down because they're going to be overloaded.
Okay. Yeah, so we might have to start getting complicated where if this web server goes down, we don't want the load balancer to just keep routing traffic to it anymore, right? So somehow the load balancer would have to know that this web server is down, and maybe we could configure this. We just introduced this microservice, so maybe we could have this include information about health. So this web server manager could do health checks, right? It could constantly be doing health checks for these and making sure that they're good. And if they're good, then it's in the list. If this one goes down, then it takes it off the list and the load balancer stops routing traffic to it. Something like that you could do. what if instead of this web server just going down entirely, what if now, random color can I use here? Anyway, so I'm gonna, this is like, it's full of water now. So this web server is now, for whatever reason, maybe it's a little laggy, or it's got some network issues, or it's handling like lots of complicated requests or whatever. But this web server is starting to get overloaded, but it's still up. Whereas this one is just like kind of hanging out, waiting, not really doing anything. So if we're doing round robin, then we're not really paying attention. We're not really accounting for stuff like that. So other algorithms you could use, again, you could have some other system that's like not only making sure that the server's up, but checking the load. And then the load balancer could proportionally distribute requests based on server load. So something like that. You might also have web servers that are like different size. You might have one, very high performant large web server, and then a couple of smaller ones or whatever. So you might want to proportionally distribute traffic. So anyway, all this stuff is fairly open-ended, but this is the kind of, the kind of stuff that you might be asked. This is frankly maybe slightly more advanced than what you can expect for your first interview, but it's good to think like this. And if you can communicate, for example, it's 9:45. All right, I'm gonna put someone on the spot now. Any volunteers?
Sure, I'll do it.
All right. Okay, so you can go just use some drawing tool. If you want to use Excalibur, that's fine. It's pretty straightforward, I think. But if you have a school of preference, feel free. And then can you share your screen?
Yeah, 1 second. Let me get Excalibur. Okay. All right. I think that works. So
Cool. Dark mode. You're hired. You're hired immediately.
thank you. It's a good interview.
Okay, cool. So Philip, can you tell me? We were talking earlier in this interview, and you mentioned your group project. Could you just tell me a little bit about your group project?
Yes. So for my group project, I made a Pokemon game, and it basically made it so that a user could sign up and authenticate to the application, and when they sign up, they are able to receive a Pokemon, and then from receiving a Pokemon, they're able to battle other random enemy Pokemon. And upon winning a battle, you capture a Pokemon, and upon losing a battle, you lose the Pokemon that lost when you're battling. And then I also implemented a shop and an inventory system for items for a user.
Okay, very cool. Thank you. So could you design me a Pokemon application?
Yes, I could go over the like the basic overview that I used, but So I mentioned that when a user signs up, they are creating basically like a trainer, is what I ended up using as a model on the back end. And so a trainer is a user once they have signed up, and then a trainer can have just
So let me just stop you real quick.
okay.
It's a little tricky. So sometimes these questions like design me Twitter or design me, especially something that you have actually built yourself. The tendency is to go into like very very low level detail about specifically what you're doing, but this architecture design, system design interview is supposed to be high level. So I don't really have to know much about Twitter. I shouldn't have to know much about Pokemon. So you're already like digging into like database tables, and what you should
Okay.
start with is the overall system architecture and components.
Okay. So I have it set up to where man, it's hard to type on this. We'll start with like we have a client, which is the user, and we have a web server that is set up, and the client is able to send a request to our web server. We have a API set up that will interface with our Postgres backend. All right, so when a client makes a request to our web server will make a request to our API and then store information about that user. And so in our database, we have relations to the user model. So there's a many-to-many relationship with a user and Pokemon, as well as items and stores. But at a higher level, a user is able to sign up and store information about which Pokemon they have, and that information is updated throughout battles. And so there are constantly requests, going from the client to the web server and storing information eventually into the database and
Okay.
then returning it.
Cool. Can I ask you a couple questions about the data model? So you said that you want to use okay, I'll say that you are using a relational database to store all your data. If you could, redesign this, would you still do that? And if so, why?
I would still use a relational database if I was to redesign this. I do think that there are some changes in the models that I would make, but it is more in like considering, I guess, future releases of the project and things that I would like to work on in the future. I realized when I was working that the models work very well, but they are set up for, fighting a computer essentially, or fighting a randomly generated Pokemon. And eventually I would like users to be able to fight each other or battle each other and trade Pokemon. And for that, I think I need to make the models more modular.
Okay, great. So when you have these Pokemon in the web app, I assume you're using images.
I am using images, but they are not my images. They are from the Pokemon API. So we're
Okay.
able to store the reference to those images because they exist as actual URLs.
Okay, great. So let's say hypothetically that service didn't exist, and you had to manage your own images. How might you do that?
I would probably implement another service and use a S3 bucket from AWS. And by doing that, you can, well, I guess I should like move this a little bit and move these. But essentially we could make it so that the client can make a request, or I could preload data, but essentially I could make it to where we have images stored on this S3 bucket, and the API is allowed to interact with it. We could set up another or the same authentication to where I guess what I've done in previous projects is I make it to where the access key for the S3 needs to be injected at runtime of the deployment of the application, and that's what will allow access for the API to interact with the S3 bucket.
Okay, cool. So why would you store images in S3 instead of in your relational database?
I don't think that relational databases are like intended to store that type of file, and then you can run into odd errors. But to me, it seems more straightforward and easier to access if you do have something like an S3 bucket, because those could be reused by other projects or other. There's a lot more reusability by putting it in an S3 bucket, in my opinion.
Okay, cool. Yeah, great. So you can stop there, but yeah, that was a good example of, you know, a design interview. And then so for the S3 bucket, I would you can definitely refer to specific services. That's fine. Like, you know, if you use Postgres for your database, but it's probably good to try to be generic. So instead of S3, you would say like blob storage, a blob storage service like S3 or something like that, or a relational database like Postgres, or an API like Django. Just because if you start getting very specific, you know, it also shows that you understand like the more general structure. Cool. Yeah. Very good. Does anyone have any questions about that kind of thing? So it's also good, I would say, even if you don't get explicitly a system design interview, it's good with your projects. You know, there's a very good chance that people are going to ask you about your projects, and if you can understand them in that way and kind of talk about them in that way in terms of how they're structured, that's also a big plus. Not just, you know, I have an app and it does XYZ, but, you know, I have an app that does XYZ and here's how I designed it. Okay. All right, let me stop recording.